Assalamu alaikum everyone, welcome back to mathematics, and we are solving A-level CI's paper Pure Maths 3, paper code 9709, variant 32, May-June 2025, and we are doing question number 4. Question 4 says solve the equation 3 cot x minus 4 cot 2x equals 3 for your range 0 to 180 degrees. Okay, what is your equation given to you? Whenever it is given to you the cot x, we change that into tan x. Okay, so it is given to be 3 cot x minus 4 cot 2x equals 3. So cot x is equals to 1 over tan x. Or you can also treat it to be, yeah, that's fine, you should be just keeping it into the tan form. Okay, so because it's also we have 2x, so that will be easier for us to simplify. So it will become 3 over tan x minus 4 over tan 2x equals 3. Now we also must be using one more identity, that is, what is tan 2x equals to? Is 2 tan x over 1 minus tan square x . So this will give you tan x minus 4 over 2 tan x over 1 minus tan square x equals 3. Now you just have to simplify this further. If something is divided in the denominator, that means its reciprocal will be multiplied with it, so that will make it 4 times 1 minus tan square x divided by 2 tan x equals 3. Now you can multiply the whole equation by 2 tan x to remove this fraction part. So multiplying will give you 3 times 2, 6. 6 minus 4, 1 minus tan square x in the bracket equals to 3. Further simplifying this, 6 minus 4 plus 4 tan square x minus 3 equals 0. 6 minus 7 would be 4 tan square x minus 1. Okay, one second, when we multiplied it with 2 tan x, we also have multiplied this with 2 tan x. Okay, so this will also become 2 times tan x, then it will be minus 6 tan x equals 0. Now it will become minus 1. Okay, let's write it in the standard form, minus 6 tan x plus 2. Taking 2 common, it will become 2 tan square x minus 3 tan x plus 1 equals 0. Now solve this quadratic. You can do it in two ways. You can either put this tan x equals to a, then the equation will become 2a square minus 3a plus 1 equals 0, or you can directly solve in tan. I don't mind doing it without substitution, but I have seen students find it difficult, so let's do it with the substitution. Okay, so what do we need? We need in the quadratic equation two things. One, one thing. How do we break the middle term? You can use quadratic formula or breaking of middle term. Okay, let's use the quadratic formula. A will be equals to minus of minus 3 plus minus square root of b square minus 4ac over 2a, that will give you 3 plus minus 9 minus 8 over 4, that will give you 3 plus minus 1 over 4, so that gives you 3 plus 1 over 4 comma 3 minus 1 over 4, so that gives you 1 or a equals to 2 over 4, that is 1 over 2. Now that means your tan x is either equals to, substituting back tan x, so your tan x is equals to either 1 or tan x is equals to 1 over 2. So x is equals to tan inverse of 1, that is, okay, I am seeing that the range is given in degree, so you must be writing your answers in degree. So alpha 45 degree, and secondly tan inverse of 1 over 2 will be (26.5650 degrees). So yeah, these will be the two angles. These will be the two solutions of this whole equation, and that is that x is equals to 45, okay, just write in the descending order, 26.5650 or 45 degree. Okay, why we are only taking these two angles? Because as tan is positive for the first one, for the first angle, and like positive, we have tan x equals to positive 1, so we need to look for only the quadrants where tan is positive. So AST, so your angle must be in the first or in the third quadrant, that will be positive. Also for the second one, tan inverse of 1 over 2, the positive, both are positive, so angle must be either in the first quadrant or in the third quadrant. So, and as we have the range just till from 0 to 180 degree, so the only angle that lies in that region, in that range, is your just angle of the first quadrant. So that is why these are the two solutions of your equation. I hope you understand this. That's all about question number 1. And these were the two identities that we have used in solving this equation. Thank you very much, and Allah Hafiz.